Hello viewers, I'm Kausalya. Today we are going to solve some more problems in transients. The problem is, in the circuit shown below, the switch is closed at time t equal to 0. Find I of t. Assume 0 current through the inductor L and 0 charge across the capacitor C before closing the switch. So here again we are having an RLC series circuit and we are having an AC voltage source, and I is the current that flows through this path, and the initial there is no charge exist across your inductor as well as your capacitor, right? So here the first step is we have to apply KVL. So KVL is nothing but sum of voltage drop is equal to sum of voltage rise in a closed circuit. So here voltage rise is nothing but our voltage source, right? So 6 into e to the power minus 2t, and we have to write the respective voltage drops produced by these three elements. So here voltage drop across resistor is I into R and inductor is L into di by dt and capacitor is 1 by z integral of I into dt, right? So this is our basic expression, right? Now the next thing is we have to apply Laplace transformation. So when you apply Laplace transformation, I becomes I of s and di by dt becomes s into I of s, and this integral of I into dt becomes I of s by s, right? So 1 divided by 0.25 is nothing but 4. And this 6 remains as such. When you take Laplace transformation for this expression, it becomes 1 divided by s plus 2. Right. So now the next step is we have to take this I of s commonly outside. So when you take I of s outside, so this is our expression. Then the next step is we have to take LCM. So once you take LCM, this is how it looks like. Right. Now the next thing is we are going to frame expression for I of s. So when you move this term to the right hand side, it comes as a reciprocal, right? So therefore 6 by s plus 2 into s divided by s square plus 5s plus 4. So this is our expression for I of s. Now we are trying to simplify this expression again. That is, you see here this is a quadratic equation, right? So now we are making steps. That is, we are trying whether we can write it as a two individual expressions. So here again, I believe you people know how to write it in two simple terms. That is, you have to find two numbers in such a way that when you multiply, you should get this number, right? At the same time, when you add, you should get this number, right? So addition or subtraction, it depends upon the two numbers, that is with their signs, okay? So here it is 4, right? So simply we are taking 4 and 1, right? So 4 into 1 is 4, and again 4 plus 1 is 5. So the factors of this quadratic equation are s plus 4 into s plus 1, right? Now we are proceeding with the partial fraction. So when you apply partial fraction in the denominator, we are having 3 terms, right? Therefore, we have to split it as individual 3 expressions here. So the next step is we have to take LCM. Once LCM was taken, this is our expression, right? So as usual, we have to find the values of A, B and C. So initially I am substituting the value of s as minus 1. When you substitute the value of s as minus 1, these two terms becomes 0, right? And when you substitute it over here, we can easily find the value of A. So just substitute the values and solve, and here the value of A is calculated as minus 2, right? In the same way, we have to find the values of B and C. So to find the value of C, here I am substituting the value of S as minus 4. Right, just substitute the values and solve. Here the value of C is minus 4. Right. Then the next step is substitute the value of S equal to minus 2, and here the value of B is 6. Right. So just substitute the values in the expression of I of S. So here you see this is our expression for I of s, but what we actually need, we need I of t. Therefore, here we have to apply inverse Laplace transformation. So when you apply inverse Laplace transform, you see this 1 by s plus 1 becomes e power minus t, and here e power minus 2t, and this s plus 4 is e power minus 4t. Right. So this problem gets over here. Again the same thing. Here we are having 3 elements in series, and the basic thing is we can solve the quadratic equation in a simple way provided if we have numbers like that. Right. That is the key thing to be noted here. Now we will proceed with our next problem. So the problem is, in the parallel RLC circuit shown in figure, the switch is opened at t equal to 0. Find V of t. Assume that the initial conditions are 0. So here this is your given circuit diagram. So this is a parallel RLC circuit. Right. And here we are having a current source. The values of R, L and C are directly given. Here we need to calculate the voltage V of t. Right. So since this is a parallel circuit, we are applying KCL. So KCL is nothing but again sum of currents flowing towards a node is equal to sum of currents flowing away from the node. Right. So here you see this is the current that comes towards this node. Right. So this is the current which approaches this node, and these are the different values of current that move away from it. Right. So here it is IR plus IL plus IC is equal to I. Right. Or else even you can think this is the total current that gets divided between these 3 elements. Right. So the next step is we have to write the expressions here. So when you write the expression, the current through the resistor is given by V by R. And current through the inductor is 1 by L integral of V into dt, and current through this capacitor is C into dV by dt, which is equal to I. Right. So this is the basic expression for this circuit, that is for parallel element. Whenever you consider current, this is our expression. Now just substitute the values of R, L and C. Right. So here the value of R is 0.2. And what about the value of L? It is, that is L is given as 1 by 6. Here we need 1 by L. Therefore it is simply 6. And the value of capacitor is 1 farad, which is equal to, what is the value of current? It is 4 into e to the power minus t. Right. So this is our basic expression. So the next step is again we have to take Laplace transformation. So 1 divided by 0.2 is 5. V becomes V of s. And here integral of V into dt becomes V of s by s. And this dV by dt becomes s into V of s, which is equal to, here e power minus t becomes 1 by s plus 1. Right. Here the remaining constants, they remain as such. Now again we are going to take this V of s outside. So when you take V of s outside, this is our expression. Then the next step is we have to take LCM. Right. Once LCM was taken, this is our expression. Now the next thing is we have to derive an expression for V of s. So we are going to shift this expression to the right hand side. Right. When you shift this to the right hand side, this appears as a reciprocal. That is s divided by s square plus 5s plus 6. Right. Again you see here we are having a quadratic equation. Right. So just let us make a try to solve this. So here you have to consider two numbers. Right. When you multiply, you have to have this 6. When you add, you have to have this 5. So the first thing is just consider 6 and 1. So 6 ones are 6, but 6 plus 1 is 7. But here what we actually need, we need 5. Therefore, this is a wrong option. So the next step is, again you select this 2 and 3. So 3 2s are 6, and again 3 plus 2 gives you 5. Right. So here we have to select this 3 and 2. So the above equation is rewritten like this. Right. So here again the same thing. Here we are having 3 terms in the denominator. So by using partial fraction, you have to split it and write it as 3 individual terms. So when you write it as 3 individual terms, you see this is how it looks like. Then the next step is we have to take LCM. So once LCM was taken, I believe you people know how to take LCM, right? Here we are having s plus 1. So this a should get multiplied with s plus 2 and s plus 3. And here we are having s plus 2. Therefore, b should get multiplied with this s plus 1 and this s plus 3. Similar way, you have to write it for c. Right. So again, we need to find the values of a, b and c. So initially, I am substituting the value of s equal to minus 1. So when you substitute here, the value of a is minus 2. Similarly, when you substitute the value of s is equal to minus 2, the value of b is 8. And again, the next thing is when you substitute the value of s equal to minus 3, here the value of c is supposed to be minus 6. So we have calculated the values of a, b and c. So here, this is your expression for v of s. Right. Now, what we actually need, we need v of t. Therefore, we have to take inverse Laplace transformation. So, when you apply inverse Laplace transformation, our expression is minus 2 into this s plus 1 becomes e to the power minus t, and this s plus 2 becomes e to the power minus 2t, and this s plus 3 becomes e to the power minus 3t. So, this is our final answer. Right. Here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.